These three, you should be able to work from what we did yesterday. All right? All three of these are supposed to be workable from yesterday. And that's the most basic one right there on the left. So see what you can do with the one on the left. See what you can do right there. That's the most basic one of the group right there. And yes, it is a UDU. And for those people that are just watching the video, this would be time for y'all to actually work on it too. But see what you can do. See what's the first thing you need to do. Come up with an idea of how to get started on it. All that good stuff. You do not have to turn this completely into U's because you don't have too many X's, but if you want to do complete substitution, you can. That's just up to you. And if you do this one, you should be able to do the second one also. Just a little difference in those two. Hint there, you can't even get the first step started. And you need to write down what your U is. Write down what your U is. Your U is always what's in parentheses with a power above it. And whatever has a power above it, you need to make your U. And you're not ready for the next step. You're jumping a step ahead. See that little 2 that you got right there? That's got to go somewhere in there, right? Which means you got to put what out front? There you go. Yeah, because if you don't put the right number out front, it won't work. You'll get the wrong final solution. Okay. You lost a 1/2 somewhere, I think, on the first one, but I'm not sure. I hadn't worked it, so I'm not sure. Okay. What I put in to make my U match up and my DU match up, as long as it's a constant, it's okay. And I always write that in a different color. If you'll get in the habit of writing in a different color, pencil, pen, something, it will help you. Okay? If you don't, you'll never know where the little numbers come from. But this way you can actually follow the little numbers. And I'm always leaving that blank because I know I'm going to need it. Oh, and someone that I just told a minute ago that they lost a 1/2 didn't lose a 1/2, did you? Yeah, you had it right. Because when you add 1 to negative 1/2, you get a positive 1/2, put the reciprocal out front, and there you go. Okay, raise your hand if you were okay with that one. Everybody follow through with that, right? U, D, U. If you did that one, is the second one pretty easy? What'd you get for the second one if you've already done it? If you haven't, go ahead and do the second one.
How do you know that your DU is 2DX?
Well, you got u equals 2x plus 1. Take the derivative of it. What's the derivative of u?
Oh, 2, okay.
Yeah, that's the key right there.
And then why do you put a 1/2 outside of the is equal sign?
Okay, if you put a 2 there, and you put a 1/2 out here, you're really multiplying the whole thing by just what? 1.
Okay.
And if you don't have a 2 there, you don't have du.
Okay, and then why does the 1/2 go back to being positive?
Okay, the rule says that if you have u raised to a power, du, you add 1 to the power, so negative 1/2 plus 1, and then you put the reciprocal out front.
Okay.
Yeah. Is that okay?
Yeah.
Yeah, the rule is if you have u to a power other than negative 1, you add 1 to the power and put the reciprocal out front. The catch on this one is, what would be the power if you tried to bring that up to the numerator?
0.
Yeah, you can't do the little add trick there. So what does this one make? What's this work out to be? What is? Yeah, it's going to be 1/2 natural log absolute value 2x plus 1 plus c, or natural log of the square root of 2x plus 1. Right, either way. But notice they both had the same u, but this one had the negative 1 power. Now, we're not always going to bring that up and write it with the negative 1 power. We're going to quit doing that. That's probably the last time I'm ever going to do that. I'm always just going to tell you, you're looking at it, you see a 1 there, it's understood to be a what if you move it to the numerator. Negative 1, right? Everybody okay with that? Yeah. Because I'm not, we don't have to keep putting that up there with a negative 1. You can work those two. You can probably make a C or a B minus in college. Now you got to be able to work the third one. What makes the third one different?
Too many x's.
Too many x's. The third one has too many x's. Yes, ma'am.
The 1/2 and the 2, why don't those cancel on this one, but they did on the other one?
Well, okay. See that 2? How'd I get that 2? I added 1 to that, and I put the reciprocal out front, and I got a 2. That's not this 2. And over here, I didn't use that rule because I got a negative 1, so if I add 1 to it, I'm not going anywhere. If I add 1 to that, I'm going to have a 0 power, and I'm going to have an undefined expression.
So you add 1 and then put the reciprocal
Out front.
Okay.
That's the rule.
Okay.
Yeah.
No, that's 1 over u, such that u minus 1 over 2u. Then you can distribute it out to u over 2u, equals 1 over 6.
Okay.
And then minus 1 over 2u.
Okay, you got too many x's, you got to turn it all into u's and du's. There's your u. You know your du is equal to what? 2 dx. So you got to put a 2 there, and that puts a 1/2 out front. That 1/2. Now, the problem is you still got an x right there, don't you? So you make x equal what? U minus 1 over 2. How did I do that? Because I looked at this step right here. Then I put u minus 1 and I put the 1/2. I put the 2 that's in the denominator, I put it where? Out front. Haven't used any integral rule yet. This is all algebra. Finish it from there. Can you reduce this fraction? Anyone? What was that fraction reduced to? You agree you can write u over u minus 1 over u? Is that okay? So what do you get? What do you get right here? What's about to appear?
1 minus 1 over u.
Yeah. Now, when you integrate the 1, what do you get? You get a u. Is everybody okay that when you integrate that constant, you get u? Because what would be the derivative of u? 1. Fair enough? Minus, and what does 1 over u du make? Natural log. Very good. Natural log of u plus c. And then you go in and you put your u's back in. Is everybody okay to put your u's back in? Notice everything from here to here was algebra. Yes, sir.
Okay, when you plug in u minus 1 over 2 in for the x, into the top x,
Right, so that's u minus 1 over 2.
whenever you plug it into like the top equation, why can't you, alright, because then
If you did, you could leave the 2 there, but what did I do since it was a constant multiplied by it? I just put it where? Out.
you can't cancel it with the 2 dx.
No, because you need, the 2 dx is how you made your what?
du.
Du. If you cancel that out, you won't have your du anymore. See, that 2, that's a good point, because that's what gets people in trouble, is they don't realize that that 2 right there is real important, because that made your du. So when you put this 1/2 out here, no, you don't want to multiply it by that 2, because that 2's about to really disappear when you integrate.
And why can you move the 1/2 outside if it only multiplies to the top?
Actually, okay, if that's your x, right?
Yes.
It's actually u minus 1 over a 2 right there.
Okay.
Think about your fraction, see?
Because of that thing that you got,
Does that help? Yes, ma'am.
you said that there should be a 2, and then is that because of you got x equals u minus 1 over 2?
Okay, that 2 right there is to make your du.
Yes.
This 2 came from the fact that that was u minus 1 over 2, and I didn't want to multiply by 2 there, so what did I do? I brought the 2 to the front. And you can bring if you're multiplying by constant, you can bring that outside of the interval.
Why do you have why do you always put a fraction outside of the?
Well, I wouldn't always put a fraction out there. If I'm putting a whole number here, what am I going to have to put out here so that when I multiply them, I get 1? The reciprocal.
Yeah.
So I'm always putting the reciprocal out front of whatever I put here. If that's not a whole number, then I'm not going to get a fraction out here. See?
Yeah.
Yeah, you're trying to, I am putting the reciprocal out front.
Okay.
Because when I multiply by the reciprocal, I'm still getting what? 1. Okay, does that help? That's a little, those are questions that you need to ask now, not in college, right? All right, good deal. That's the reason we're teaching it to you now. Now, when you look at the answer in the back of the book, you're not going to have it unless you think for a second. Because you're going to write 1/4 2x plus 1 minus, and I'm going to go ahead and put the 1/4 in front of the natural log. I'm going to distribute the natural, and I'm going to get natural log 2x plus 1 plus c. And then you're going to say, well, that's 1/2 x plus 1/4 minus 1/4 natural log 2x plus 1 plus c. And you look at the back of the book, and that's not the answer. Here's the answer in the back of the book. And they just put a plus c out there because it's just a constant. But really, is this c and this c equal to each other?
No.
No, it's what we do. We just added that 1/4 in. So anytime you have something like that, don't let it scare you. If you're adding a constant here, what are they going to do with that constant? They're going to add it out there. Because if you leave it like this and you take the rid of it, you're still going to get what right there? 0, and you're still going to get what right there? 0. So that constant really doesn't matter. Yes, sir.
So I didn't bring the second 1/2 out. So
Okay.
I got u over 2u minus 1 over 2u. And then would that
Yeah,
be
that
L-
works.
Would that be ln of 2u? Or is that?
Okay, you got it. Well, u over
Just use log rules and just.
separate out. In other words,
2 plus
you got it.
1 unit.
okay, if you were going to integrate 1 over 2x dx, right?
Yes, sir.
If you make this your u, then you're going to need 2 here and a what? 1/2. All right?
Okay.
Now, and let me show you, everybody listen to his question, because that's something that will mess you up when you're trying to integrate like that, when it's multiplying.
So it's not just ln 2x.
No, it's 1/2 ln of 2x. Now, everybody watch. Everybody looking up here for what he's asking about, because that, okay, if you have the integral 1 over 2x dx, the easiest way to integrate that is make that 1/2 integral 1 over x dx, just factor the 1/2 out, right? And then make it 1/2 natural log of x plus c. I know there's supposed to be absolute values, but everybody does. All right, now, but he's saying, no, Mr. Evans, I didn't do that. What I did was I said, I have 1 over 2x dx. I made the u equal what? 2x. So the du would be what? 2 dx. So in order to do what you're wanting to do, you have to put a what here? 2 and a 1/2. Then you would get 1/2 natural log of 2x plus c. And everybody goes, well, those don't look the same. Yes, sir?
Can't you just use like logarithm rules and do ln2 plus ln
1/2
and add it to c?
times natural log of 2 plus natural log of x plus c. 2 times that, that's just going to be a big old what? Constant. So you get 1/2 natural log of x plus, and there's your big old constant. So they both work. And it's nice that they both work because that's how it's supposed to be. It's math. It's supposed to work as long as you're following the rules. And that's just the thing on this. Anytime you're multiplying by a number, try to get that out of the way. It just makes life easier.
Rick, can you leave that up?
Mm-hmm. Now, and the too many x is all right. When you don't have enough x's, that's when life is really bad. All right? Too many x's, most of the time, is going to work for you. Too few x's, life is real bad. Okay. Happy so far? Ask a question before it disappears, please. Now, if you solve this,
Yeah.
you can integrate each one of them separately, right? Everybody okay with that? And just bring the 3 out front. In other words, do 3 integral 1 over x minus 2 dx plus 4 integral 1 over x minus 3 dx. Is that okay? And then, what are you going to get when you integrate that? You ought to be able to see that without even writing it down. That's going to be a what?
Yeah.
Natural log. Yeah. X minus 2 plus 4, natural log of what? X minus 3 plus C. They're both supposed to have absolute values. You don't. If you're at LSU or at Tech, you probably have to put the absolute value signs there. If you're at MIT, you're supposed to know that they have to be positive. They don't require you to put the absolute value signs. Okay. They also use LOG for natural log, which can get. Yeah, MIT, if you see LOG, they mean natural log. Okay, they don't have any other base logs. Unless they write it down. Okay, is that cool? Is that all right? All right, well, so, if I had the integral x plus 3 over x squared plus 6x plus 5 dx. You want to try to make your denominator the u. Is everybody okay? The denominator is going to be the u. Is everybody right on that? So write it down. Write down what your u is. X squared plus 6x plus 5. Take the derivative of that and you get what? 2x plus 6 du. What is the only thing you got to do to this one? This is an easy problem. So all you got to do is 2 what in the numerator? Put in a 2. You're going to put a 2 here and you're going to put the reciprocal out front. And then you're just going to get 1/2. And does everybody agree that if you move that up to the numerator, it's going to have a power of -1? Right? It's going to have a power of -1. And so you're just going to get natural log of all that. Plus C. All right. Chump easy. That's a u du, and it's not even hard to make du.
Why did you put the du times the dx?
Ma'am?
Why did you put the du number in front of dx? Like in the problem.
Oh, because it's 2. I got to multiply 2 times. That is all, that, and that make the du.
Okay.
Yeah, all that makes the du. Yeah, all of this right here makes the du. And sure, yeah, you could have put it out there on the end and put a 1 there if you wanted to, because you know it's multiplication. And you know you could have moved it all out to the end.
And that's the constant, right?
The 2 is a constant you need, yeah. And so I put the reciprocal out front. Because look, you need your derivative to be what? 2x plus 6. Well, 2 times that, you got it.
Okay.
All right? That's a nice one. Okay. Well, here we go. Okay, we're going to look at that and we're going to say, hey, let's make the u the denominator. Everybody okay with that? We would say make u equal the denominator. But are you going to have du up there in the numerator for you? No. And notice you don't have enough what up in the numerator? X's. You got too few X's. Yep. This is not a good old basic u du, because if you make all of that your u, you don't have du up there because you're missing an x. You need an x up there. 2 little x's is always real bad. Well, does anybody notice something about the denominator?
Factor it.
It factors out nicely. So if you don't have enough x's and you've got one of these fractions, the first thing you want to do is see if it factors out nicely. If it doesn't factor out nicely, that's another level of integral. But when it factors out nicely, life is good. And it factors out into x plus 2, no, x plus 1, x plus 5. Or x plus,
X plus 3.
x plus 1, x plus 5. It doesn't factor out like I wanted it to, but that's okay. X plus 1, x plus 5. Does everybody agree that makes 6x in the middle, 5? Yeah. Now, and if you don't know how to factor like me just there for a second, it's really bad. And I'll put my dx. If you put the dx right here, it's okay. Put the dx there, because 1 times dx would still put a what? Dx there. Now here's what I want to get at. If I had an integral that had x plus 1 in the denominator, plus another fraction that had x plus 5 in the denominator, did we realize just a few minutes ago that that would be real easy to integrate if that was just a constant here and a constant here? We just did that, didn't we? Just move the constant out front, integrate that, move the constant and integrate that. In other words, if this could be written as 2 separate fractions, if we knew the values that would go into those numerators right there so that when you added it together, you would just get a 1 and get this fraction, we could integrate this and this, right? Now, why am I allowed to separate that apart as 2 fractions being added together? Because if you were to add these together, what would you have to do to add them together? You'd have to find A. And what do you do to find the common denominator? You do what to them? Multiply them together. So what you're doing is you're undoing the addition that got you to there. You're turning them into 2 fractions that when you add them together, they will make that fraction. And the problem is the numerators are not going to be 1 and 1 because when you add them together, they got to work out to give you a 1. And if you put a 1 there and a 1 there and you add those together, you're going to get like 9 in the numerator or something like that. Okay? You're not going to get 1. So we're not sure what number needs to be here and what number needs to be here, but if we knew those 2 numbers, this would be really easy to integrate. That's going to make a natural log of x plus 1. That's going to make a natural log of x plus 5. We just don't know what constants need to be in front. Is that okay? Now we've already tested to make sure it wasn't a du in the numerator to begin with because we didn't have enough x's. And then we've looked to see if it's factorable. The next problem is an algebra problem. A over x plus 1 plus b over x plus 5 has to equal 1 over x